Hello and welcome back to Engineers Olympiad. We're continuing with our series of weight-volume relationships in geotechnical engineering, and we're solving the numerical questions. For this topic, we have solved many numerical questions, and this is, I guess, the video lecture number 9 for the same series. 8 video lectures are already uploaded on the channel Engineers Olympiad. You can watch those videos before watching this video. Alright, so let's get started. Question is, the mass of wet soil when compacted in a mold was, it was how much? 1.955 kgs. The water content of the soil was 16%. If the volume of the mold was 0.945 liters, determine dry density, void ratio, degree of saturation, and percent air voids. Take G equal to 2.68. Alright, so let's solve this question. We're trying to solve as many numerical questions for this topic as possible. Alright, so let's get back to the question once again and see what it says mass of wet soil when compacted in a mold was 1.955 kg. So this is the mass in the wet condition or the bulk condition or the moist condition. The water content of the soil was 16%. If the volume of the mold was 0.945 liters, determine the dry density, void ratio, degree of saturation, and percent air voids. Alright, we have been given mass in the wet or the bulk condition or the moist condition, that is how much? 1.955 kgs. 1.955 kgs. Volume is how much? Volume is, if the volume of the mold was 0.945 liters, so it is 0.945 liters. Let me calculate the bulk. We have been asked to calculate dry density. For that, I'll calculate the bulk density first. Bulk density is mass per unit volume, but which mass? Mass in the bulk condition or the moist condition or the wet condition. So that is 1.955 kgs divided by volume is 0.945 liters. I'll convert it into meter cube. That means 1 liter is equal to 10 raised by minus 3 cubic meter. So here it is this. Alright, upon calculations, this becomes 2068.78 kgs per cubic meter. This is the bulk density. Alright, or I can say this is the bulk density or moist density, alright, or wet density or bulk mass density. So bulk mass density is 2068.78 kgs per cubic meter. Now I'll be finding the first parameter that the question asks us to find, that is the dry density. How? Because I know the water content, I will simply use this equation. Dry density is equal to bulk density divided by 1 plus water content. So dry density is bulk density is how much? 2068.78 divided by 1 plus water content. Water content has been given as 16%. The water content of the soil was 16%. So here it is 0.16. Upon calculations, dry density is equal to 1783.43 kg per cubic meter. So the first part is complete. Done. We have found dry density, which is equal to 1783.43 kgs per cubic meter. Now void ratio. We'll be again using the same formula for dry density, but the alternate equation, that is dry density is G. This we have calculated. Now I can get E from this equation. Alright, this is this 1783.43. G is 2.68 as per the question. It has been given. Take G 2.68 multiplied by density of water 1000 kgs per cubic meter divided by 1 plus E. Upon calculations, this is 1.502. So E is 0.502. void ratio has been calculated, 0.502. That means parameter number 2 has been calculated. Now degree of saturation. Degree of saturation we can find by the generalized equation. Degree of saturation, S is equal to Wg by E. We know W, we know G, we know E. We can calculate degree of saturation. See how? Degree of saturation is water content is 16%. G has been asked to use as 2.68. E we have calculated 0.502. So S becomes 85.41%. Alright. Degree of saturation becomes 85.41%. Now, the last thing that we need to find is the percent air voids. Alright, percent air voids. That means the percentage air voids. Percentage air voids. It is the ratio of the volume of air to the total volume. Ratio of volume of air to the total volume. Alright, this I have to find. Now I'll be using a generalized equation wherein dry density has been related to this percentage air voids, and that is this 1 minus Na, where Na stands for the percentage air voids, so the percent air voids, G 1 plus Wg. This is the generalized equation or the alternate equation to find the dry density when we will be having the percentage air voids, which is the ratio between volume of air to the total volume in the soil sample or the soil mass. But here we know the dry density, we know the G, this, and this. We can very easily calculate the percentage air voids or the percent air voids. See how? Dry density is how much? It is 1783.43. Let me write it over here. 1783.43 kgs per cubic meter. This is 1 minus Na. Na we have to find. G is 2.68. Density of water is 1000 kgs per cubic meter. 1 plus water content is 16% and G is 2.68. Alright. So this becomes 1783.43, 1 minus Na, right, multiplied by 2680 divided by 1 plus this becomes, upon calculation, 0.4288. By further solving, this 2548.16 is equal to 1 minus, when I multiplied this with this, 1 minus Na multiplied by 2680. That means 1 minus percentage air voids is 0.9508, or percentage air voids is 0.0492, which is equal to 4.92%, because we express it in terms of percentage. That's why it's known as percentage air voids or the percent air voids, which came equivalent to 4.92%. Alright, so with this we have completed question in all respects. We have found the dry density void ratio, degree of saturation, as well as the percent air voids. Alright, let's do the next one. Question number 63. Question number 63 says, alright, a compacted sample of soil with a bulk density of a compacted sample of soil with a bulk density of 2 grams per centimeter cube has a water content of 15%. What are its dry density, degree of saturation, degree of saturation, and air content? Take G equal to 2.65. All right, so this is the question and we have to solve this one. Question is, a compacted sample of soil with a bulk density of 2.0 grams per centimeter cube has a water content of 15%. What are its dry density, degree of saturation, and air content? Take G equal to 2.65. All right, we have been given bulk density and the water content. We have to find the dry density. We know dry density is bulk density divided by 1 plus water content. All right, so in this case, bulk density has been given. That is how much? 2 grams per cc. So dry density is, bulk density is 2 grams per cc. So it is 2 divided by 1 plus water content is 15%, 0.15. So upon calculations, dry density becomes 1.73 grams per cc. What are its dry density and degree of saturation? For dry density has been completed, we have solved it. For degree of saturation, I must be having, if I'll be using the generalized equation, E S is equal to Wg by E. This I have, but void ratio I don't have. So the first attempt is to know or to solve for the void ratio. For that, I know the dry density. I'll be using the alternate equation for the dry density so as to arrive at the void ratio. See how? Dry density is also given by this equation, G or W divided by 1 plus E. Dry density we have calculated, it is 1.73 grams per cc. So here it will become 1.73. G as per the question is how much? G we have to use as 2.65. All right, this is the specific gravity of the soil solid particles. So 2.65 goes here. Density of water is 1 gram per cc divided by 1 plus E. E we have to find. We are doing everything for just having our void ratio. 1 plus E is equal to 1.531. That means E is equal to 0.531. With this, we have our void ratio. Now we can very easily calculate our degree of saturation, and that's the next parameter that the question has asked us to find. All right, what are its dry density, degree of saturation, and air content? Dry density we have done, which was equal to 1.73 grams per cc. Now we're solving for degree of saturation, and then subsequently we'll solve for the air content as well. Now S as per the generalized equation, or the degree of saturation, Wg by E. That means S is equal to water content is 15%. G question says to use as 2.65. 2.65 divided by E we have just calculated as 0.531. So S becomes 74.85%. 74.85% is the degree of saturation. Now the last thing that remains in this question is the air content. Air content, I'll be again using the same equation that I used in the previous question. The alternate equation, the alternate generalized equation for dry density is 1 minus Na. All right. First, I'll be arriving at the percentage air loss, and then subsequently I'll arrive at the air content, because air content is a different thing. Air content is volume of air to the volume of voids, whereas percentage air voids is volume of air to the total volume. See how? I'll be using alternate equation of dry density to arrive at percentage air voids first, and then subsequently to the air content. We'll be doing our calculations. All right, 1 minus Na G rho W 1 plus Wg. Dry density we have found. It was how much? In the very beginning, 1.73 grams per cc. So here I'll write 1.73, 1 minus Na, G is 2.65, rho is 1 gram per cc, 1 plus water content is 15%, and G is 2.65. Upon calculations, this Na is 8.8%. Alright, upon calculations, Na is 8.8%. That means percentage air voids is 8.8% Na. Percentage air voids, which is the ratio of volume of air to total volume, is 8.8%. And as the name indicates, it is usually, we cannot say always, it is always represented as a percentage. All right, as its name suggests. All right, so now we have percentage air voids, but the question asks us to find the air content and not the percentage air voids. See how we'll be rhyming at that. We know that one more equation is that percentage air voids is equal to porosity multiplied by air content. All right, but I know percentage air voids, I have just calculated it as 8.8%. I know void ratio, I can calculate porosity, and then I'll be having my air content. Now see, first let's find the porosity. Porosity N is equal to E divided by 1 plus E. E we have calculated, E was equal to how much? 0.531. Alright, 0.531. So this becomes 0.531 divided by 1.531. So this becomes 0.3468. And as we express porosity also in terms of percentage, so this becomes 34.68%. All right, now by the generalized equation where percentage air voids is equal to porosity multiplied by the air content, that means air content is equal to percentage air voids divided by porosity. All right, so air content is percentage air voids is how much percent? It was 8.8%. N is how much? It is 34.68%. Porosity is 34.68%. So upon calculations, this is 25.37% air content. Alright. Air content is also usually expressed as a percentage as we express the percentage air voids. So both percentage air voids and air content, they are expressed as a percentage. Alright, and interrelationship between percentage air voids, porosity, and the air content is this. So with this I have completed the question. In all respects, we have found the dry density, the degree of saturation, as well as the air content. All right, let's move on and do the next one. Question number 64. All right, so question number 64 is question number 64. All right, see, a sampler with a volume of 45 cubic centimeter is filled with soil sample A sampler with a volume of 45 centimeter cube is fitted with soil sample. When the soil is poured into a graduated cylinder, cylinder, it displaces 25 centimeter cube of water. What is the porosity and void ratio of the soil? What is the porosity and void ratio of the soil? What is the porosity and void ratio of the soil? Alright, a sampler with a volume of 45 centimeter cube is filled with soil sample. When the soil is poured into a graduated cylinder, it displaces 25 centimeter cube of water. What is the porosity and the void ratio of the soil? Very good question. Let's solve this. Total volume of soil sample is total volume of soil sample is how much? A sampler with a volume of 45 centimeter cube is filled with soil sample. Alright, so if this sampler, which are usually cylindrical in shape to take the soil sample from any side, is having a volume of 45 centimeter cube and it is filled with the soil sample, that means total volume of soil sample is 45 centimeter cube. Volume of water displaced, volume of water displaced volume of water displaced is how much? When the soil is poured into a graduated cylinder, it displaces 25 centimeter cube of water. So this is 25 centimeter cube. See, since the sample is poured into a graduated cylinder, the volume of soil solids is equal to the displaced water volume. Alright, since the sample is poured into a graduated cylinder, that means the volume of soil solids is equal to the displaced water volume. I write it down for you. Since the sample, after it was collected using a sampler having a volume of 45 centimeter cube, then it was subsequently poured into a graduated cylinder and there it displaces 25 centimeter cube of water. But since the sample is poured in a graduated cylinder, the volume of the soil solids is equal to the displaced water volume. Right? Definitely it will be the volume of soil solids which will be equal to the displaced water volume. But I'll write it for you. Since the sample is poured into a graduated cylinder, the volume of soil solids is equal to the displaced water volume. That means displaced water volume is how much? It is 25 centimeter cube. That means volume of soil solids which will be equal to the volume of soil, this water displaced, which will be 25 centimeter cube. Alright, so we have volume of solids as 25 centimeter cube. Now I can very easily find the volume of voids. How? Because I know the volume of solids, I know the total volume, I can very easily arrive at the volume of voids. Volume of voids is equal to total volume minus volume of soil solids. So voids' total volume is 45 because volume of the sampler is 45 centimeter cube. Volume of soil solids is 25. So volume of voids is 20 centimeter cube. Alright. Now what the question asks, what is the porosity and the void ratio? Now I can very easily find the porosity and void ratio. See how? Porosity denoted by N is volume of voids divided by total volume multiplied by 100. So N becomes, volume of voids is how much in this case? It is 20 centimeter cube. Total volume is 45 multiplied by 100. So N, or the porosity, is 44.44%. Alright, porosity is 44.44%. And question also asks us to find the void ratio. Porosity we have done, now the void ratio. Void ratio, we know the porosity, we can very easily find the void ratio by using this equation. N divided by 1 minus N, right? It's minus. Or I know the ratios, since void ratio is equal to volume of voids divided by volume of solids. I know volume of voids, I know volume of solids. I can use this equation also to find the void ratio, either of the two, this or this. All right, so volume of voids is how much? Volume of voids we have calculated here, 20 centimeter cube. So here it is 20 divided by volume of solids. Volume of solids is how much? It is 25 centimeter cube, because the volume of soil solids in this case is equal to the volume of the water displaced when the sample, after it was collected using a sampler having 45 centimeter cube as its capacity or volume, when it was thereafter poured into a graduated cylinder, there it displaced 25 centimeter cube of volume of water, which is actually equal to the volume of soil solids. All right, so here it is 25. So upon calculations, this becomes 0.80. That means void ratio is 0.80. Right, so this is how we have calculated this question, and we have found the void ratio and the porosity, whereas porosity was equal to 44.44% and the void ratio was equal to 0.80. All right, so with this question is done. Let's move on to the next one, question number 65. All right, question number 65. Question number 65 is a long question. All right, listen carefully. Earth is required to be excavated from borrow pits. Earth is required to be excavated from borrow pits for building an embankment. For building an embankment of height 6 meters, top width 2 meter, and side slopes of 1:1. Alright, earth is required to be excavated from borrow pits for building an embankment of height 6 meters, top width 2 meters, and side slopes 1:1. The unit weight of undisturbed soil in the wet condition is 18 kilonewton per cubic meter. The unit weight of undisturbed soil in the wet condition is 18 kilonewton per cubic meter, and its natural water content and its natural water content is 8%. The dry density required in the embankment the dry density required in the embankment is 20 kilonewton per cubic meter, with the water content of 10%. With the water content of 10%. The specific gravity, it's a long question, but a very, very good question. The specific gravity of the soil solids is 2.70. Estimate the quantity of earth required to be excavated in the borough area to constant 1 meter length of the embankment. 1 meter length of the embankment. If each truck has a capacity to carry 80 kilonewton per trip, what is the number of truckloads required per meter length of the embankment? What are the values of porosity and degree of saturation on the embankment? What are the values of porosity and degree of saturation on the embankment? Alright, so this is the question and we have to solve this. Let's read it once again. Earth is required to be excavated from borrow pits for building an embankment of height 6 meters, top width 2 meters, and side slopes of 1:1. The unit weight of undisturbed soil in the wet condition is 18 kilonewton per cubic meter and its natural water content is 8%. The dry density required in the embankment is 20 kilonewton per cubic meter with a water content of 10%. The specific gravity of soil solid particles is 2.70. Estimate the quantity of earth required to be excavated in the borough area to constant 1 meter length of the embankment. Alright, so first we have to do this. We have to estimate the quantity of earth required to be excavated in the borough area to constant 1 meter length of the embankment. Alright, now the second part is if each truck has a capacity to carry 80 kilonewton per trip, what is the number of truck loads required per meter length of the embankment. All right. And then subsequently, the last and third part is what are the values of porosity and degree of saturation on this embankment. All right.